Spectrum is a graph of intensity of light on the y-axis compared to the wavelength or frequency or energy of light emitted and or absorbed on the x-axis. So basically we're looking at a graph. And this graph has intensity labeled I on the y-axis compared to wavelength along the x-axis. Intensity you want to think of as amount. We're looking at the amount of light being emitted at a particular wavelength. Now this particular object is hot and dense and is emitting a continuous spectrum. Notice we see no breaks in the colors. We see solid black, then red, solid red, orange, yellow, green, blue, indigo, violet, back to solid black. It's a continuous spectrum. And once again, the vertical axis is the amount. So this particular object is emitting more green light, because it's the highest amount is green, compared to violet light. So it has more green being emitted than purple. We can look at a different spectrum. This one's a continuous spectrum, and this is another example of a spectrum. This one's an emission spectrum. In this case, we're looking at a less dense object. It's still emitting light. So it's emitting reds and oranges and greens and blues and violets, but they're only emitting discrete colors. Think of just a few colors out of the Crayola crayon box. And we're looking at particular wavelength numbers of these colors. Let's look at this purple one, for example. This is the intensity of light, so it's emitting this much intensity of light, or this amount of purple. Let's compare it to this red one. Well, compared to the red one is half the amount of the purple one, roughly half the amount. So this particular object is emitting more of this purple light than it is of this red light at these two wavelengths. But if we compare another shade of red, such as this wavelength right here, it's emitting more of this red wavelength than it is of the purple. So we're looking at the vertical axis as the amount of light being emitted, and the horizontal axis is the wavelength number. You can also put, instead of wavelength, you can put frequency number down there, or you can express it in terms of energy. Another example of a spectrum is an absorption spectrum. The absorption spectrum looks like the continuous blackbody spectrum, but in this particular case, we're looking at a cool gas that's absorbing blackbody light. So we have an object emitting continuous blackbody light, but that's not the subject of our study. Our study is this gas that's between us and this black body, and that gas is cool and it's absorbing some of this blackbody light. So you see this absence of color. So we're looking at these white lines here, or an absence of particular colors out of the Crayola crayon box. So this is an absorption spectrum. Each one of these is a spectrum, and this is what we mean by spectrum.